In the last video, we solved this using polysimult and found that my three planes intersected in a line. But what would happen if we had done it algebraically? Well, if I start by subtracting these two equations, then I'll do this equation 1 minus equation 3. So if I do 1 minus 3, that's going to give me 0, negative y, plus 2z equals 3. And I could also think about, I want to get rid of x again, so I could multiply this equation by 3. So I'll get 3x, 6y, minus 15, and now subtract these two. So, or I could subtract this way, doesn't really matter. It doesn't matter at all, in fact. So if I subtract this way, negative y minus 6y, that's going to be negative 7y, plus 14z. 6 minus negative 15 is going to be positive 21. Well, I can see straight away that these two are multiples of each other. So if I multiply by 7, I'm just going to get that 0 equals 0, which is, of course, true. So since I ended up with my variables canceling, I'm going to think of them in terms of each other. So this one implies that y is equal to 2z minus 3. Notice that's what I've got up here. So z has become my parameter, and I did that only because I had this y by itself here. Knowing this for my y, I can come substitute up here. So I could say that x is going to be equal to 2z, let's write it out from the start. So x plus 2z minus 3 plus 2z, that's going to be plus 4z minus 3 equals negative 2. So x is negative 4z plus 1. Same thing I have up here. So now z is my parameter, so my line of intersection, x, y, z, becomes, for the x, I have 1, negative 3 for the y, 0 for the z, plus multiples of z, negative 4, 2, and 1, because z became my parameter. But I don't use z because I already have a z variable here, so I'm going to use lambda. So that's what it would look like algebraically.